All right, now that I got it here on the bench, I can see that the insulation and the wires are completely trashed all the way right up to the where they go into the alternator here. So it's as I suspected from when I started peeling this back. It's just the corrosion has just practically migrated all the way up here. So I'm gonna, all this green you can see is copper wire that is corroded. So that's just completely trashed. So we can get rid of that. Well, you know what? I'm gonna keep that off to the side just for a moment because I might want a measurement off that. Okay, so you're probably wondering how the hell am I going to fix this? Or you might be wondering why the hell am I going to fix this? Well, if I am going to get this motor running, it is going to need an alternator. And a new replacement alternator, I think this part is actually still available, believe it or not, but it's crazy money for what they want for this thing, which is a complete ripoff for what it is, really. I could buy a complete electric motor with a larger stator in it than this thing, or armature, and for less money than what they want for this. I'm wondering how far in this wire goes before it transitions to the solid enamel covered wire that's potted in this. Because here's my plan. Cut this away to the point where I can get to the solid enamel wire, resolder on new copper braided wires, epoxy this back in, kind of pot this back in with epoxy, and voila. This is almost like a rubber plug, but it's not. It's kind of plug that's going to unplug. This is like some kind of a little hole goes down in here. I don't know how far. Well, everybody, it's a Sunday morning, and I managed to sneak down to the basement, do a little work down here. It's been a couple weeks since I've been down here doing anything. Been pretty busy. Spring has sprung here in New England, which means there's a lot of work to be done out on the property. Cleaning up around the yard, cutting some of the brush before it gets too unwieldy, things like that. Also have work that I've got to do on actually all of the trucks need work, so I'll be doing work on the trucks, and probably won't be filming that only because it tends to slow down the work. The little Dodge Dakota got a rejection sticker for several items that I've got to address, so that's time sensitive. I got to get that done because that's my everyday driver. And the big white Dodge Ram, we just got to do ball joints and a front wheel bearing or hub assembly on that. That might be helpful to some people to see how to change one of those out, so maybe I'll film that. I don't know. We'll see. It's just tough when you're doing any of these jobs, when you add the component of the camera and just repositioning the camera, stopping, starting the camera, and everything like that. It can get kind of it can really slow down the flow of the work. What else is going on? Let's see. Haven't bought anything groovy in a while. As far as tools go, haven't done anything on the lathe or the mill in a while. Not much really going on. Trying to get back to this outboard because, again, like I said, spring has sprung. All right, so let's get to it. So when last I was down here working on this thing, I was trying to get to the point where I could expose where these wires actually make the transition to the actual solid copper wire that's wound around these windings. and had discovered that this is kind of like a little pot area right here that's filled in with epoxy, and was having trouble digging this out. I just can't go hog wild and try and, you know, really be aggressive with some kind of a tool and drill this out. I've got to be real gentle because I don't want to go too far down and damage the winding. There's also a metal ring right here. It almost appears like maybe they actually epoxied in a metal sleeve for the wires to go down through. So that's just wonderful. So I think what I'm going to do is I'm going to start by trying to shave off this area around here with a Dremel tool and see whether or not I can't get this ring popped out. And the hope is that eventually I can just get down to a point by lightly grinding, get to a point where I can reach that transition before I actually reach the top of the windings, because this section right here is far thicker than the rest of the unit. So what I'm talking about is this section right here is thicker than this section. So it's pretty straightforward. You can see that the windings are just wound around each one of these little arms of laminated core. But when you get over here, this core and this core is all done together. So there's a pronounced V or valley in between these. So right here in this valley is where they stuck the sleeve with the wire connections. So my theory is I should be able to grind out this valley and get to those wire connections that I want. Better get my coffee out of the way. There might be some chunks of stuff flying. Hey everybody, I'm going to interrupt this video right here. I was just in the middle of editing it, and I just wanted to talk about what I ended up doing here. You know, my idea was pretty sound. Remove the potting material, expose the transition point between the braided copper wire and the solid copper windings, and then reattach attach new wires at that point, and then repot this whole thing. That's basically what I end up doing in the end. But you can see I run into a few problems here, and the biggest problem is that I end up damaging the windings inadvertently. And at first I thought I completely destroyed it, and then I ended up pulling a rabbit out of the hat, so to speak, or so I think. I actually haven't fully tested that alternator at this point. But I just wanted to give a word of warning to anybody who's contemplating doing this kind of a job on one of these alternators. If you've never done it before, you've got to be really, really careful not to damage the windings. I ended up getting a little too aggressive with my removal of the material, and I ended up paying a price in adding a lot more time to the repair than what was going to be originally necessary, and B, even if this alternator does work, it's not going to work as good as it should, because I ended up having to remove several turns off of a couple of the windings. But that, you'll see all that all unfolds. All right, so now let's get back to that video. All right. So maybe I won't go down to the transition point. Maybe I'll stop right here, because I have now gotten to the point where I can, where I've effectively been able to, I think, isolate the two little packs of strands of copper wire. Now that copper wire is corroded, but I might be able to clean that up enough to solder to it. Literally flow solder right into the braid is what I'm thinking. That'll give me two stiff little posts to stick up to attach new wires to. Just gotta make sure, I'm looking at with the magnifier, because you gotta make sure there aren't any little tiny strands, stray wire just sitting there causing a short. So the heck of it, let's see what we're getting for a reading resistance wise now. it was really low. And I couldn't tell whether or not I had a short still there somewhere that I couldn't see, or whether or not this just has a very low resistance for the winding. I mean, 1 ohm. Yeah, I mean, I'm getting 0.6 or 0.5. The leads themselves. Sometimes you get bad connections here from oxidation and cause that kind of a reading. There you go, 0.1. That's more like it. All right. That just seems way too low. All right, well, I decided to hook up my Z meter. This is a capacitance inductive analyzer, and sometimes you have a inductor that will have a very low resistance, but there's still inductance there. So you can't just rely on a low resistance reading as an indication that there's actually a short or a problem with the inductor. So what the inductance meter does is it actually can measure the actual value of the inductor in the whereas the value for capacitance is farads, the value for inductance is henries. But just like with capacitors, where you rarely have actual farads, you have divisions of very small amounts of farads, which would be like microfarads or picofarads or nanofarads. With inductors, you tend to have microhenries, or more commonly millihenries. So this is an auto ranging meter, so you just hook the inductor up and it measures the inductance. So the first thing I noticed was I hook this up, I look at the value, it's measuring at about 92 or 93 microhenries, which is very low inductance, as opposed to, I just happen to bring the ignition coil over since it's the only coil I had handy, and if I look at the value of the ignition coil, that's actually measuring, actually the ignition coil appears to only be measuring about 13 or 14 microhenries. Oh, wait a minute, I think I just looked at this wrong. No, alright, so there's actually more inductance in this. But what troubles me about this is that when I hook up to this and I do the ringing test, okay, which the ringing test, essentially you hold down this button right here and you rotate this impedance matching knob, and you rotate it to a position where you get at least 10 or more rings. Well, the problem I'm getting is that I can only get about 1 ring out of this thing. Okay, ringing an inductor, for lack of a better explanation, without getting into all the technical mumbo jumbo, think of it as think of the analogy of a bell, ringing a bell. Whereas you strike the bell and it rings, and the sound that it rings out is a certain frequency. Well, you have all different sized bells, which when rung will give you all different sized frequencies. So each bell resonates at a particular frequency when struck. Well, each inductor will resonate at a certain frequency when it is not mechanically struck so much as electrically struck. So what this device is doing is this device is essentially acting like an electric hammer and trying to get that conductor to actually ring or oscillate. So it's kind of like looking for almost like an echo back of the initial frequency that's being struck into the inductor electrically. maybe that's not a really good explanation. But all we need to know for intensive purposes today is that I would really like to see this inductor kick back more rings. So here's the again the ignition coil, and if I rotate this to that position there, I get 14 rings, which is more than 10. So that would indicate that this is a good coil. So the question is there actually a problem with this inductor, or is it just a matter of that because of the type of inductor that it is, it's not expected to ring? Like I said, there is inductance there. It's measuring 94, 90, around 90 microhenries, as opposed to, like, say, if it wasn't dead short. Simulate that by shorting these two leads together, then you see it's way out of range there. So I don't know.
Well, that wire is really corroded. It's giving me fits trying to solder to it. So I decided I was going to try and peel this back even further, and discovered that this is just a fiber disc that the wires are fed up through. So by pulling that disc off now, I could probably go back to using the Dremel tool and burrow even a little deeper into here. See if we can't get to that point where where this wire transitions to the solid copper wire.
Well, anybody who watches my videos knows that I'm not big on hiding my mistakes. So here's a doozy. I shouldn't have used that Dremel tool to try and cut down in here. It turns out the actual transition connections between the enamel wire and the wires that were attached to them happens way down inside there. Matter of fact, it's almost better to get in from the back side here by the looks of it. What you end up with is there's a little metal crimp right here, a little crimp connector that attaches the braided wire to the enamel wire. But the problem is that I ended up, in the process of trying to get down in that tight spot between the coils there, I ended up breaking a couple of the windings, and then I compounded things by thinking that, well, if I could maybe unwrap the bad windings, maybe I could bridge them out. And so I tried to take off this top piece here, and I tried to cut it with a chisel, and I cut too deeply, and I actually drove the chisel into this side right here and badly damaged this. So I've got numerous broken windings now. I also can't figure out now where one of these two connections went because it broke off while I was trying to take it out. One goes right here, but that's all academic now because basically I turned this into a big lump of garbage. So that was a mistake. I also, since doing this, have found out that there's actually a guy on eBay who offers a service to repair these for this exact problem, which is the corroded, the bad insulation on the wires. So he's figured out a way to open this up, put new wires on, and then repot this with epoxy, which is what I was which is what I was attempting to do, but because I have no idea what I'm doing, destroyed this. So even if I wanted to avail him of his, I believe, $150 service to do that, he requires your old alternator winding as a core, and then he'll send out one that he's already made up, and then eventually he'll sit down and repair yours and just, keep swapping them out that way. So at this point now, if I were to approach him, he would probably have to charge me extra because I don't have a good core because of what I did here. So by the time he gets done charging me, it'll be probably $200 or more.
And for that kind of money, I can actually buy the aftermarket alternator. But I'm not going to do any of that. I'm going to hold tight for a good used one. And if that doesn't pan out, well, then I might just have to rethink this whole thing. Maybe there's another way to generate the AC off of this motor. I don't know. Well, that's kind of disconcerting, to say the least, that I did that.
Hey everybody, it's another Sunday morning and I snuck down here to the basement. It's been actually probably a couple weeks since I've been, excuse me, take 3. Sneak down to the basement here.